Hello and welcome to The People's AI, presented by Vana. I'm your host, Jeff Wilser, a journalist who covers the intersection of crypto and AI for CoinDesk and the like. And today we are tackling one of the most fascinating and I'd even say sneaky underrated topics in all of AI, robotics. Where are we now with robots? How far away is a mainstream robot future? And why is better data essential to that vision? And I'm proud to partner with Vana to bring you this podcast. Vana's mission is to promote user-owned data to help create user-owned AI. The core principle, you own your data. So Vana is creating a system of data DAOs to let you connect with others, join forces, sort of like a data labor union, and that gives you levers to profit from your data. That's also the spirit of today's guest, Bayley Wang, the co-founder of a new robotics project called Prisma X, which describes itself as a base layer for real-world robotics. Now, Bayley is a super interesting guy. He spent many years at MIT as a robotics researcher, and he worked on many of the early cutting-edge robot prototypes. He eventually realized that for robotics to truly scale, we need better data. So he launched Prisma X, which is essentially a platform to connect real-world data provided by users with the robotics companies that are hungry for this data. And broadly speaking, Prisma X is partnering with Vana to help bring user data into the fold and create better robotics. Prisma X recently came out of stealth at an A16Z demo day. And the idea is that you can be rewarded for sending videos of real-world actions like folding laundry or even operating actual robots remotely. You log into your laptop and you virtually control some robot 1,000 miles away. As Bayley describes in our conversation, right now, today, there are billion-dollar organizations that are begging for people to virtually operate their robots, kind of help them move around and get insights, get data. And they're having a hard time making this happen. Prisma X is building a system to enable this at scale. Zooming out the lens, for me, robots almost symbolize something magical about the future, something straight from sci-fi. I personally think of them as more Jetsons than Terminator. And I love the vision of a future where a robot will clean my bathroom, scramble my eggs, fold my laundry. How far are we from that future? And what will it take to get there? This is what we will explore in today's conversation with Bayley Wang, the co-founder of Prisma X. Bayley, welcome to the People's AI.
Thanks for having me.
So I am fascinated by robotics. I know many of our listeners are too. So we're going to get deep into the nuance of what you guys are building and how data fits into this. But let's start at a more macro lens. What is the current state of play of robotics, right? You occasionally see YouTube videos of cool things happening, but you also don't see any mainstream adoption. How would you describe where we're at this moment with robotics? What are robots good at right now and what are they not so good at? What's your high level look at that?
Yeah. So robotics is an interesting field, right? Because it combines both difficult hardware challenges and difficult software challenges. And uniquely among any of these fields, in robotics, the hardware challenges got solved before the software challenges. So between, I would say, about 2010 and 2019, the industry put in a huge flurry of work on actuation and generating the forces needed to make the robots work. So nowadays, as you said, you see these crazy YouTube videos of robots doing parkour and front flips, back flips, barrel rolls, but you don't really see the robots being in the wild because they don't really have the intelligence or planning to be able to complete real tasks.
So am I hearing you right? The hardware is maybe surprisingly far along. It's the software that's lagging, which surprises me because my thought naively is that it's the physical world and the hardware that makes this all more complicated than Gen AI, which is growing by leaps and bounds in the past 2+ years?
I would say certainly the necessity to own hardware is a barrier to scaling, but the hardware problem itself is solved. Like if you ask me to design you a robot of some shape, there's a set of off-the-shelf or nearly off-the-shelf parts you could put together to make it happen.
Got it. So what are the main kind of pain points of why we're not seeing more? I mean, I go to AI conferences and you often see little prototype robot scurrying around. They look like dogs almost. You see things like that in very crude prototypes. They're clearly nowhere near ready for prime time. So what's holding us back?
Yeah, so I think really what's holding us back is automation, like having these robots be able to go out and do things and complete tasks on their own without any sort of human intervention. And for that, we need better AI that can interact with the physical world. Now, AI that interacts with the real world is a tricky thing, right? When you go use ChatGPT, if the answer is wrong, you're like, oh, that's kind of stupid, and you try again. If you go deploy a model like that on a robot, like it's trying to clean your kitchen, and you come back and 10% of the dishes have been thrown on the ground, you're going to be very angry, and you're definitely, like, try again is not really what you want to do. You're going to be very angry and, I don't know, like, never use that robot again. So the accuracy requirements are harder. The real world is also very diverse. Like even just saying this robot runs in a kitchen, there's a whole lot of different shapes and sizes that the robot has to be able to navigate. And some people are trying to do it with like a rules-based approach where they use machine vision to generate like a list of items in the scene, then a VLM to go try to plan the tasks. But you have a lot of like rules written by humans in there, and those rules tend to break down when the people who wrote them didn't expect a new type of scenario.
Am I right that rules-based approach, is that analogous to before kind of LLMs and the transformer architecture in Gen AI? The idea was we will label, right? We'll say, hey, this is a cat, this is a dog. And so then they realize, okay, the kind of transformer breakthrough, realize you don't have to do that. You can just feed a shitload of text and data, and the transformer will kind of figure it out and make its connections on its own. Is it something similar happening in robotics that instead of having all of these kind of rules-based logic, that there's a more elegant way to get these robots to move their hands and claws?
Yeah, so modern rules-based approaches are a little more sophisticated than the ones from like the early mid-2010s because we do have LLMs and VLMs now, and they can pick up a little bit of the fuzziness, right? So if you want a robot to clean a kitchen, you can use the LLM to go plan out a set of actions and then use a more conventional approach to find the objects in the scene that those actions might correspond to and have the robot go like move its arms to the coordinate of the cup and then move it to the dishwasher. But the actual like planning was done by an LLM, so it does account for some level of fuzziness, but still fundamentally this process is a rules-based approach. The humans are writing rules and making assumptions about what the environment will look like, and those assumptions tend to break down. It's one of those unfortunate things that even the best teams of developers are nowhere near omniscient, so they can't plan for everything. And that's why the LLMs are so powerful, right? No one writes the rules for the LLMs. They see a cross-section consisting of like tens of % of the entire internet, and by doing so, they're able to capture a little bit of everything. So while LLMs sometimes hallucinate, they very rarely are horrifically incorrect. Like they generate semantically and syntactically correct English, they generate plausible outputs. It's sort of like the difference in robotics between the robot picking up the dish and like throwing it on the ground versus the robot, say, picking up the wrong dish and putting it in the wrong container, right? Like the first one is not very good, but the second one you can at least sort of like put up with. Or in language modeling terms, it's the difference between getting the wrong answer versus getting something which is just a string of words that don't even make any sense next to each other.
I'd love to get a little more into your personal background and kind of what brought you to Prisma X. And I think that might give listeners a good sense of where are the particular pain points in robotics and how data fits into this. Tell us a little more about your journey from MIT to what you're building now.
Yeah. So I was a robotics researcher at MIT, and I was part of one of the teams, the Mini Cheetah team, that helped solve this hardware problem by making the actuators a heck of a lot cheaper and easier to get. But when it came time to decide whether we took that robot and we made a commercial spin-off or we just like let it rest and went back to doing research and doing other things, we made the very active decision to not try to sell the mini cheetah. The MIT robotics team is probably one of the only great academic robotics teams without a commercial spin-off. And the reason we did that is because we couldn't figure out how to get the robot to do anything useful.
For those who are not familiar, what was the mini cheetah, and talk about kind of what it did and what it...
Yes. Yeah. So you've probably seen these robot dogs that have been running around. The mini cheetah was the first like commercially manufacturable robot dog. It was built using advanced what they call quasi-direct drive actuators, so high force, but also very easy to measure like what force they're exerting. And it was built using mass production techniques, using parts off of like drone supply chains. So it was a little dog about the size of like about 2 feet long, and it could do all kinds of things. It could run, it could jump, it could do a backflip. But as I was saying, when it came time to figure out what this machine could actually do in the real world, all we could think of was very expensive robotic pet for rich people. And we floated the idea of like putting it on Kickstarter for like several $1,000s, but decided it just wasn't a scalable market. And in the end, we were right. There are a lot of companies in this crowded space building robot dogs, but they're just being marketed as toys right now because no one can figure out the software to make them do things.
In fairness, I guess some of these designer lap dogs, you know, if you're wanting to buy a particular breed of like hypoallergenic dogs, you do spend like $4,000. So I guess like, hey, it's cheaper than
there is a small
dog food.
There is a small market that I would say is about the same size as people who buy $5,000 hypoallergenic dogs, but that's also not a like venture scale market.
Yes,
like, you can't venture fund your dog.
That should not be one North Star for an addressable universe.
Yeah.
Okay, so you're just like, all right, this is a fairly hyper niche thing. We can probably find or hopefully find a more scalable, better use case and better kind of like type of robot that does more than just like freaking backflips for the hyper wealthy.
Yeah. So after that, we just sort of went off and did our own things. I went and worked on a company doing displays and optics. But robotics has always been top of my mind and things that I'm interested in, and things that I think are really high impact. So, you know, a couple of years ago, GPT-3 showed the world that large-scale unsupervised training on huge data sets was incredibly powerful, and the resulting emergent behavior could do crazy things. So everyone started thinking about robotics again and how the same types of software and same types of workflow could make robotics better. But when you come and do robotics, you immediately run into a data problem, like a data problem, a scaling problem, where if you want to train a model which handles text, you go download the whole internet and you go do your training. When you want to train a robotics model, step one is to collect data, and then you like stop because it's really annoying to collect data. It requires hiring hundreds or thousands of people to do the data collection to really do anything meaningful.
Famously, Google had to, like when originally to try and get Google Maps to work, right? It had to, in Google Street View, they had to get like cameras on cars and drive thousands or probably millions of miles around the world in the physical world to get to see, okay, here is the real world. It's one, but prior to that, Google is like, cool, we can just on web searches, we will own this. But then you try and get the real world, it's a lot more physical infrastructure you have to stand up to do that. And so that's relatively simple compared to the idea of streets and highways is a relatively simple thing, I'm guessing, compared to the messiness of your robot and kitchen example earlier. Imagining all of the granular, if the countertop is sloped a bit, right? Or if there's wind, air friction, how fast the robot's arm moves. That sounds in a way much more complicated than like predicting the next word in a sentence, and arguably more complicated than, cool, I'm on Main Street and next to me is First Street and here's what the neighborhood looks like. Am I warm as far as my idea of how complicated this is in a physical sense, and where it's a struggle to figure out how do you hoover up enough data to be able to make meaningful predictions?
Yeah, so robotics is a little more complicated in terms of the sensor modalities that are really needed relative to some of the other tasks. But the way you think about it is this, right? Like, say you wanted to learn how to make a French omelet, you would probably go watch a video of how to make a French omelet, and because you have additional knowledge about how your fingers interact with the world and how to pick things up, by just watching that video, you can learn how to complete the task. Mm-hmm. And I think with robotics, it's going to be a similar situation. We're going to have low-level models that are trained for that particular hardware, probably on data from simulations, in order to learn how to hold objects without crushing them and understand things like friction. But the higher level models, the ones that require a huge amount of data, are the ones that then teach the robot how to complete tasks. It also circles back to this question of hey, do you need force data to be able to train a robot? And my answer to this is probably not, because when humans want to learn how to complete new tasks, I don't have to pick up your arms and carry you through the motion of making that omelet in order to teach you how to make an omelet, right? You're smart enough about the world from your interaction, basic interactions with it, to learn how to do this task. And sure, for very complex tasks, like if I asked you to complete a advanced manufacturing task, I would probably have to also give you a few trials. But I think that parallel also draws to robotics, where maybe you do large scale training on visual data, then for the final run you go operate the robot to go interact with the environment a bit in order to learn a little more about the forces and the friction and the materials.
So tell us about what brought you to, and what kind of led to Prisma X and your light bulb of, okay, given the challenges of gathering data in the real world, we need some other solution.
Yeah, so fundamentally what inspired Prisma X is this idea that diverse large data sets and diverse large operator environments are what powers these models and makes them robust. If you a lot of the decentralized data projects are saying we can provide data for cheaper, but for robotics, it's about providing the data that works. And I think that's a unique opportunity where the decentralized project has very strong potential to be the state of the art and and beat out all of the centralized projects, right? Because if I'm a centralized project, and even if I had the money to go hire 1 million people to collect data for me, I still don't know who to hire. I need to select the split of 1 million people that I think best represents the world. And I would argue that you will always wind up with manager's bias in a situation like this. It's very subconscious in your mind that people will plan for the things that they're familiar with and the things that they find important, right? And this is a problem. You wind up with a model and an AI and a robot which is tailored to the preferences of a committee of 20, 30 people who maybe they tried their best to plan, but in the end it was not successful. If you let the community evolve organically, you wind up with a sampling of the world which much more closely corresponds to what people care about in the real world, and that gives you robustness. It's emergent behavior, right? Decentralized networks have emergent behavior just like models trained on large-scale data, and I think that's important. It gets rid of as many rules as possible and lets it evolve according to a very simple economic target of this task has value, or this task is one that people do more frequently. And that's what led to this idea that by using decentralization and by using protocols to coordinate millions of people, you could scale robotics up much more quickly than you would be able to with any sort of centralized project. And the rest of just fits together.
That makes complete sense in theory. I love that framework. Talk about what it looks like in reality, or kind of be concrete. So as I understand it, it's a robotics data DAO. What does it look like? What are some examples of how people are feeding data to the system and getting compensated for it?
Yeah. So we work with a few data modalities. So fundamentally, Prisma X addresses the 3 core needs of robotics: data, teleoperators, and models. And what that means is that people who are participating can either submit more passive environmental videos of themselves completing tasks, all the way down to just, here are the videos on my phone, and the protocol will discover which of these videos are important, which of these videos are useful, and provide rewards for them, up to something like, here's a first-person view video of myself completing some tasks, either requested by a customer or just passively, all the way to people on the network can use the protocol to go remotely operate robots, and that collects probably the highest quality modality of data. But you see, there's like barriers to adoption, right? You can either be a very passive reward hunter, just upload your videos, some of it will be useful, get some rewards, all the way to like, I'm putting in real work, and like, when you operate a robot, that's not just like accumulate network tokens for later. That's like a business which can reward much more valuable immediate incentives. Like right now, right? Like robotics companies are paying $50 an hour for this kind of operator. So there's like a direct value translation for guild operators, for robot operators to be able to immediately engage with the industry and like just make a business, make money out of it.
I heard about one concrete task where users are submitting videos of themselves like folding sheets. Can you talk a little more?
Yeah.
Is that an accurate example? What are things people are doing, and maybe kind of connect the dots of how that kind of video they're filming can eventually feed into robotics in action?
Yeah. So the sheet folding project, we're doing it because domestic robotics is a field which is just very interesting in the robotics industry right now. There are a lot of companies that are trying to tackle this. It aligns well with, hospitality use cases, hotel use cases, where there's like a pretty clean GTM for the robotics. And it's something which everyone has, right? Like everyone has towels or sheets they can fold. So it's very accessible for the
It's also low stakes, right? If the robot screws up the sheet folding, no one's going to die, right? Unlike self-driving cars, where if they make a mistake, oops, pedestrian is killed. So
exactly.
It's a great low-hanging fruit. I agree.
Yeah, so then looking at how this exactly works, the idea is that if you had, say, 10,000 hours of videos folding sheets, of people folding sheets, you get a lot of diversity to be able to address like all kinds of environments, but at the same time, the task is repetitive enough that it's easy for the AI model to pick up on how to do it. And it's similar to like if you watch 100 hours of videos of someone doing the same task over and over again, it's much easier to learn that task than if you went and watched 100 hours of random tasks. You would learn basically nothing. And the exact way this works is, not to get like too deeply technical, is the model will go sort of watch those videos and learn the repetitive patterns in those videos without ever having them labeled. Like, it doesn't need to really know what a sheet is or what an arm is or what a hand is. It just sees the same things happening in the videos over and over again and builds a strong internal representation of those patterns. Those patterns, the latents they call them, are like very compact. They contain a lot of information, and the model has learned to extract that information. That then gets decoded by like they call it an body specific model, in order to directly output things like the gripper positions or the joint forces needed to actually complete the task. So that way you can take your huge data set, train a big model once to generate these like representations. Then for each of the robots you want to ship against, you would train a much smaller model on a much smaller amount of robot specific data in order to be able to do the like robot specific action decoding.
So minor follow up on that. This sounds very maybe like silly question, but does the angle matter? I was imagining if most people, when folding sheets, I'm imagining if I'm videoing myself folding sheets, maybe if I hold it with my hand, I do it one way, or if I put it across the room the other way. But if all of the videos the robots are seeing are filmed a certain way, are there blind spots? So do you have to do you encourage users, say we are, what's really useful is videos from a reverse angle or below angle. And I know this is a kind of a bizarre question, but I think it gets at some of the complications and nuance here of the complications of the real world, right? So like if how much variety and richness do you need in different kind of like angles of folding sheets, for example? And I think everything in the real world probably has similar types of complexity of how do you get enough like 360-degree views to give the robot a good sense of, okay, here's what's actually going on?
I think sheet folding is a somewhat, I would say, not unique, but like in the minority of examples where the sheet is likely to obscure a large part of the view for a while. So for this particular example, I think video from the front and back would definitely be helpful. But in general, the robot if the robot sees enough video, it should gain an understanding of how the world works in order to be able to sort of guess the obscured views from the visible views. For like the specific sheet folding example where we're collecting data to address a single task, you probably do need multiple views in order to be able to do the synthesis, because you don't have a lot of data in like of other tasks to be able to learn what the hidden parts look like. But if you can imagine, if you had enough data, you would have view, like when the robot would learn when its arm was being obscured, what it was doing. Like it would learn to guess from like videos where its arms weren't obscured. So I think in general for foundation scale modeling, you don't really need an explicit like every task needs to be recorded from every angle. And this sort of like jumps into another interesting question of like, where does the camera need to be?
Yeah.
And a lot of people are like, oh yeah, you need egocentric video, you need like specialized sensors. I don't think so. I think if you go set a camera on a desk and then like do things, that contains a lot of information already. And sure, it doesn't match the point of view of the robot's cameras, but that's fine because the model should be able to learn how to extract the actions anyway from that point of view, right? Like I once again, like doing the biomimetic analogy, you don't need to watch a first-person view video of someone completing a task to learn how to do it. You're smart enough to deduce where your arms go from like a video from any angle. And what's important is that the view is relatively unobscured and it's like reasonably high resolution.
Makes sense. And okay, so we've covered sheet folding. What are some other concrete examples of use cases that people are feeding data through?
I think probably the most interesting one in the short term is going to be warehousing and restocking. It has really good alignment with what the types of communities that engage with decentralized projects are doing anywhere. Like there's a lot of people who are like gig workers or like work in like convenience stores or retail. And it also has a very immediate use case that there are plenty of companies that are either trying to do last mile light warehousing or restocking or like some sort of like light mix of domestic commercial. Easy data to collect. You could wear a camera like on your chest as you go about doing your work and just passively collect that data.
Tell us a little more about what this looks like as far as incentives and compensation, and where are we in the timeline? To what extent is this already out there in the wilds, and give us a sense of kind of what the adoption has been like so far.
Yeah, so for our project specifically, we've really been working more on the demand side with robotics companies, and for the supply side, we're going. I think initially we're going to work with like there's folks like Vana that already have data enthusiast communities. There's also guilds like YGG, which were focused on more gaming type things, but want to move into something which has more real world value. And these people are already used to the structure of like incentive hunting, either for tokens or for points that convert to tokens in the future. And I think for the data collection stuff, it's really no different. The interesting thing I would say is for robot teleoperation, like part of our network and our protocol also covers directly being able to connect to a robot and operate the robot to complete tasks.
Is that remote? I'm trying to visualize this remotely, or literally they go to a place and they put their hands on a robot?
Remotely.
Okay.
You remotely operate the robot through, like, it could be as simple as a keyboard and a joystick or VR or something.
Okay.
And that type of task has a more interesting incentive structure right now, because there are customers that are willing to, like, they're paying $50 an hour for that service right now, but they can't scale. So that's like a very robust business, right? Like they're like, not only do they not want to pay $50 an hour, but more to the point, they do not know how to scale these robot operators. Like the team is like you have companies with a valuation of over $1 billion running a team of 8 people to do their data collection right now, and like,
wow,
one of the people is like a founding engineer, that kind of situation. So being able to offer something which is a lot more scalable is really helpful. And there's a lot of interesting things you can do there. Like, we encourage guild formation, because guilds can not only go and like organize the operators on the ground, they can also do things like invest in a robot that can be operated to generate data and mine incentives. And that's really helpful for the robotics companies as well, because that means that they can like at least break even on the hardware, like sell it at cost to a guild for the data collection, rather than having to like raise dilutive capital for a manufacturing round in order to like get to the point where they can even start collecting data.
Amazing. Say a little more about how this works as far as compensation. Is there a token? How is a DAO fit into this? What are kind of the Web3 mechanics here?
Yeah. Of course, there's a token, right? We're a decentralized project, and what else would we do? But the DAOs are sort of their organizational units to manage access to the data and sales to the data, so that we don't have to go manage all of the data ourselves. The way the tokenomics work is that it's similar to like any other data project, I think, or what the other data projects should be if they're not already doing this. That new data contributed to the network generates new tokens, because that's like new value being retained by the network. Then the transactions themselves happen through like a token buy and burn mechanism, and that's where the DAOs sort of come in as well, right? Like central buy and burn is somewhat regulatory suspicious in many countries. So by having the DAOs, you sort of allow that to happen, and it's up to the DAOs to go manage the data access.
What's the token called, and where should listeners go to learn more if they want to get involved with this?
Yeah. So our project is called Prisma X. The token will be called Pix, PIX, but it's not live yet. So right now, the best way to follow us is you can follow us on X at PrismaX AI. We also have a sort of portal gateway where people can get engaged, upload some existing data, and interact with the platform.
You've been in stealth for a while. Coming out of stealth, talk about what that pivot from stealth, what you're launching with, and then about demo day. I'm eager to hear what you guys cooked up.
Yeah. So we've been in stealth for the past year or so, mostly working on the demand side to engage with robotics companies. We're coming out of stealth, and we want to build out our community of people who are excited to help advance the new frontiers of AI and robotics. Right now, we came out of stealth. We were part of the A16Z CXX SF cohort. We recently closed the seed round, and we're coming out of stealth with just a basic early portal right now to be able to let users interact with the platform. You can upload some of your existing data. You can go out and collect some existing data, or soon you'll be able to also reserve robots and be able to teleoperate them in order to generate new data. And that's an exciting part of the platform as well. There's a lot of data collection projects, but there's no two-sided data collection projects yet where you engage with like someone else's hardware, someone else's product to collect data for that product. And I think there's a new level of value here which we can really capture.
Dude, I would like pay money for funsies to operate a robot remotely.
Exactly,
and you're saying,
right? Like,
someone's going to pay me to do that. That's right. Cool.
Like, people will go to like a theme park and like pay $15 for the special ride where they go into VR and like become the robot.
Yeah.
And I'm telling you right now, there are people who will pay you $15 for you to operate that robot, because right now the CTO has to go operate the robot himself to collect the data, and he really should not be doing that.
Well, so tell me a little more about these companies. So you're saying this actually exists right now. There are robotics companies. You said earlier, $1 billion robotics companies. They're like, shit, we have these robots. We need remote workers to come in with a joystick or keyboard and move this robot around the factory. That is currently
exactly. Like probably right now at this very moment, as we make this podcast, there are robots being remotely operated to collect data by companies that have raised collectively billions of dollars, but they do not know how to deal with the operator fleets. Like, it just doesn't make sense for a highly technical team of researchers to also handle what eventually needs to be thousands of data collectors. So there's like an incredible opportunity here for decentralization, right? Like the platform, the de facto platform for these operators who can immediately engage with an industry on something that they need like today, right now, but don't know how to do.
So the Prisma X platform, I get at a high level, it connects users who want to, let's say in this example, they want to get paid $15 an hour or whatever it is to use their keyboard and move the robot around. Again, like very cool. Do you guys provide the actual like operating system, the UI to do that? Or is it more giving the token in the future to the user and then the robotics company is like has their own UI? How does the mechanics work there?
Yeah, we want to provide the standardized like OS and UI and setup so that from the operator's point of view, it's very consistent. They log in with either a browser or a VR device or even a phone and are presented with tasks that they can interact with to collect incentive. And once they log in and start operating the robot, they get a very consistent user experience so that the like experience they learn operating one robot transfers to other people's platforms. Like, I think that's important, not just, it's very important from a UX, it's very important from an operator UX point of view because it makes things consistent. It's also very important from the industry's point of view because it means that these like 100, 200 robotics companies don't have to each redo their tech stacks in order to do that, right? And I think that's a really cool opportunity. By building the technology for these robotics companies that's also implicitly tied in with our protocol and our incentives, we sort of drive a lot of adoption. People will come in and like use the free tools we provide to build their robots in order to like sort of short circuit several months and several $100,000 of dev time. And then from our network's point of view, every team using that is additional value for the network. It's another type of robot, another potential customer that's on our network that the participants can engage with.
Got it. And congrats again on your recent demo day with A16Z. Talk a bit about what you unveiled and showcased there.
Yeah. The A16Z's demo day was a pretty short, like 3-minute presentation. But against that backdrop, we came out of stealth on X. We unveiled the portal so that people can start engaging with the platform if they're excited about it. And we're sort of like unveiling this plan for people, like ordinary people, to be able to engage with what is an emerging multi-billion-dollar industry. Right now, it's only a multi-billion-dollar industry, but it's going to be hundreds of billions of dollars down the line, right? Potentially, as they say, like replacing all of the labor in the world.
Let's go there now. Well, let's pivot to the future. What excites you most about robotics use cases in the future?
Yeah, I think there will be more and more robots, and the way the world is going to shape up, I don't think people are going to get replaced by robots. I think people will work as the back end of robots to do things like make sure robots complete tasks reliably, do teleoperation. So it's not like people will no longer have jobs. It's that one person will be able to do the work of 7 or 10 people, and that means a heck of a lot more time to either do more or like make the same money doing less, and then like having more time to go like do the things that people actually find enjoyable. As far as concrete use cases go, I'm really excited to see robots step into tasks like I don't know, kitchens and restaurants are I think a big one. Food is important to everyone, I'm sure. Like, everyone needs to eat, and I think that with technology there's a lot more opportunities to like branch out and do something different. If you have more automation, that means your restaurants can like it's not just about being cheaper, right? It means like your restaurants can be more diverse, serve more interesting dishes. The humans have more time to be creative and like leave the actual repetitive work to the robots. I would say among the near-term use cases, that's probably the most interesting one. Like, you'll see it, you'll feel it, and your life will become better and more exciting because of this technology shift. As far as the long term goes, the end game vision for everyone, I think, is a robot in every home where you can wake up and like all of your chores have been done for you by the robot. But this is probably the most challenging of robotics use cases, and I think it'll take us a little bit of time to get there.
And I fully agree with you on so much of that, especially the idea that there are some really obvious, wildly useful applications like cleaning. Like as I've had other guests in my podcast say, hey, you're telling me a robot can come and like clean my toilet? Like, yes, please. Who's not going to want that? Who's like, no, it's important to me that I clean my toilet the old-fashioned human way, right? So if you're cheap enough, of course we'll have robots scrubbing, mopping floors, cleaning toilets, and so on. What do you think is the biggest obstacle to overcome to get to a world where, let's call it, the toilet cleaner robot is mainstream? What will it take for that to be ubiquitous in daily life?
The answer is very simple. In order for the toilet cleaning robot to be mainstream, we need a heck of a lot more data. Because that robot needs to be able to get to your door, that's data. It needs to be able to navigate through your house, find the toilet, and like know how to clean the toilet. And there's a lot of diversity right there. Every house is different, doors are different, layouts are different, and that robot needs to be able to handle all of this. And I could probably right now build you a machine which, using conventional machine vision, like finds your house, opens the door, and then like navigates to the toilet and cleans just the toilet. But it would be pretty useless. It wouldn't do anything but clean toilets. So in order to have like enough value to ship, that machine needs to be able to do a lot of things. Right. And for that, we need to scale up. And I think there will be a bridge. I think there will be a bridge where we go from videos of people cleaning toilets to teleoperated robots cleaning toilets, all the way to autonomous robots cleaning toilets.
What's your prediction of how long that will take?
I used to say 10 years. But one of my friends who's good at robotics as well told me that was too early of an estimate. So these days I avoid giving a hard estimate. But I think it's going to be about a decade before the technology really gets to the technology and the models gets to the point where we can handle general domestic tasks. It may be less for some of the high value ones like cleaning, but we'll leave that for the founders to go find those tasks.
Okay, last question for you. I won't pin you on a hard timeline, but give us one other prediction of out there in the future of how you mentioned at a high level earlier that we'll have more time to do things we actually enjoy. Give us a little more concrete prediction of how our lives and how the world could be different in the, let's call it 5+ years in the future. What might surprise people of how basic life looks?
I think what's interesting is that 5 years in the future, the robots will silently like be part of your life, and you won't really notice it, but you'll find that your life has just gotten better, right? Like you'll be able to like go to a restaurant and things will be much more timely because there are robots working in the back to make sure that like things are getting done on time. You'll be able to go to a hotel and things will be cleaner, and people will be working to engage with you and give you a good experience rather than going around and like folding the sheets and doing the laundry, because there will be robots handling that. But they won't be highly prominent in 5 years. I think that this idea where like robots look like people and walk around and just see them on the street, that's a little ways off. It's sort of like the early days of AI, right? Like we got cool features like better Google Translate and like Google reverse image search, and that was all AI. Those were all based on like embeddings and transformers, but they weren't like in your face. Like they were just silently making the world better. And the big moment like was ChatGPT, where you like explicitly interacted with the AI. And I think maybe someday you'll explicitly interact with the robot, but I'm also not sure that this is the world where you want, right? Like where the robots are like squarely in your face all over the place. Maybe what you want is a tool that like silently works in the background to make your life better.
Bayley, love that vision. Congrats on coming out of stealth. Really enjoyed the conversation and looking forward to seeing where this goes. Congrats again. Thanks.
Yeah. Thanks for having me.
Well, there you have it. Thanks again to Bayley Wang, the co-founder of Prisma X. And thank you again to my partner, Vana, for helping bring this podcast to life. Vana's mission is to promote user-owned data to help create user-owned AI. Vana's system of data DAOs are helping to make that a reality. And thank you again to you, dear listener. If this is your first time at The People's AI, please subscribe at Apple, Spotify, YouTube, all the usual places. Rate it 5 stars. Find me on Twitter/X at Jeff Wilser. Thanks again, and see you next time.